Hey, so I don't think I've done a little face cam thing for a while. Anyway, it's an awkward start, wasn't it? So we're going to look at the badge today. It's done, essentially, pretty much. Again, very awkward. Yeah, it's done. I've designed it. I've tested it on a breadboard. I've transferred that circuit to a schematic, and I've created a board layout. And we'll go through those bits. But I'll cover a couple of the sort of areas first. So we'll look at a couple of the bits of the board and look at it in a bit more detail, or I'll explain some of it. But hopefully it won't take too long. I think the last time I did a face thing was when I was talking to Sion, I think. I haven't done a response for him yet. I think I might even have told him that I've done it, but I haven't edited it. I haven't even recorded it. But I have made some progress. So there was this. I put something out on Twitter about this. It is the filament display coming along. Baby steps on this. So I've not put all the other segments in, but we'll look at that another time. All right, let's get started. So I told you that I was making a badge and that I would show you the circuit. And the circuit's with a 4017 and a 4027 and a 555 in a stable mode. Now, I'm not going to show you the 555 thing because I only have one lying around that works at this voltage. So, but I will show you the schematic for that. So the actual circuit, not demonstrated individually. Now, I think we know what a JK flip-flop is. That's the 4027. I've actually covered that in one of my videos on the 4000 series. Now the 4017 I also covered, but I want to go over it in a little more detail because it's a hugely versatile chip and it's really cool and it works very well with LEDs. So this was the circuit I showed you before. We've got 20 LEDs with a JK flip-flop which alternates which side of the LEDs are working with the 4017, which is a decade counter. Now I can unplug this and let it free run, or I can plug it into pin 3 on the microcontroller on the 555. I was going to say I'm not using a microcontroller, I'm using a 555. And so this is free running. And I can alter the frequency by covering up an LDR, which is creating a voltage divider. So you can see with the bright lights that are in here, it goes pretty fast. The resistance on the LDR reduces, so the divider voltage changes. So there we go. That's the circuit, and that's what my badge is going to be. And we'll go on to the sort of schematic for that in a minute. It's fairly simple circuitry, but it is spread out on a massive breadboard. Let's just unplug that and bring over the demonstrator board, which looks a lot nicer. And this one's ground. It's currently running off 3 volts, so I might change it for these LEDs because they're a little bit dim. Oh no, they look okay actually. I don't know if you noticed when it cycles the power on, it actually has a sort of junk in the memory of the chip because I don't do a reset on start. But this is the function of a 4017. You put a clock pulse in, which I'm doing with a button there. See how fast I can press that. Not very fast. So you can see with every press of the button, it increases the count. Now, this is basic. Oh, I've got some dodgy connections here. This is basically straight out of the datasheet for the 4017, but we can also trigger it with something else, and this is what I'm doing with the 555. I'm using a separate trigger, and in this case, I've got the little clock module that I made, and I'm breaking out, I think 32 Hertz. So let's take it out and pop it in. So now we've got a nice regular clock pulse going through. You can see that we can choose any off this IC actually, and you can see some fairly fast ones. Oh, and there'll be some slower ones in here somewhere. There we go. So that looks to be about 2 Hertz. That's 0.5 Hertz. And then over here on other parts of the chip, you can see some very, very quick ones. The camera's sort of strobing with those actually. They are going through. So let's disconnect that for now and let's have a look at the schematic. Now this is the schematic for my badge. You can see I've got the 4027, I'm using half of it, and so one half of the JK flip-flop, which is switching our transistors Q2 and Q1. We've got our battery over here. Next part of the circuit is the 4017, the decade counter, and it runs LEDs 1 to 10 and 11 to 20. And you can see them on screen here. We've got LED 1, LED 2, LED 3, and so on down to 10. Now these ones, their ground comes from this 2N3904, which is an NPN transistor driven by Q1. Now next to it we've got another transistor which is driven by Q2, another 2N3904, and that is running 11 to 20. So it goes down this row, gets to 10, which is Q9 output, and then you've got the carryover signal just here. Now this is when it gets to the end of that cycle, the next pulse goes through that carryout and to 0, Q0, the output 0, and that carry out signal comes into the clock of the 4027, which then flips that output over. So it reverses these two flip-flops, as it were. So that flip-flop then changes one of these transistors to be on and the other one goes off. And so we get the pulses then going through these ones instead, and around and around and around it goes. So I'm using a 555 timer, which works well with lower voltages. And this is the TS555. And this one will go down to below 3 volts, which is what I want. Now, it also draws very little current. So it's something like 100 microamps. So with this circuit here, we've got our LDR, which is on pads at the moment. You'll see on the board layout why that is. We've got our VCC coming in through a 3.2K resistor. Now, I've done this not based off any calculations. I know that you can use calculations to figure these things out, but I don't know them. So I was just playing around with some resistors and found some values that worked for me. Control voltage pin here, I've got that through a cap to ground, but you don't really need it. It does say in the datasheet that's what you should do, but it worked well for me without it, so I may not even put it in. And then you've got your trigger cap here as well. So that is the circuit, and this is the board layout. Now, I'm not good at drawing. I'm not an artist in any way, shape or form. However, I can use Inkscape, which is a vector drawing program, which is what I've used to draw this out. And then I saved it as a SVG file, which is scalable vector graphic. And so what that does, it plots out all of these points as data rather than as image data. So not pixels, but paths, essentially. And then I've imported that through one of the user language programs or something like that. I don't know what a ULP stands for, but in here somewhere, if I can find it, is an import SVG thing or a DXF. I can't remember the details now, and I certainly wouldn't be the best person to show you how to do it, because I had to try about 10 or 15 times before it actually came in and stayed normal looking. Lots of times it was too big, sometimes it wouldn't complete the outline and I had to try and draw it in, but because I'm working on a specific grid, you can't really join these lines together. So anyway, eventually it worked. There are lots of tutorials. SparkFun have a really good one, which is the one that I followed. Now the clock itself has LEDs that go around the outside. In fact, let's turn off the stop player for a second so you can see that properly. So we've got LEDs here all around the outside. Those are the LEDs that are attached to the 4017. We've got the 4017 and the 4027 just here. They're sitting on opposite sides of the board, and we've got the 555 timer just down here along with its components. Now the LDR is going to sit underneath the badge or poking out the side. I'm not sure yet. I've put it close enough together so that you can just replace it with a resistor and have it fixed if you want to, but long enough so that you can put the long leads of the LDR on there. Now I'm going to be making this available. It'll go on my website at some point. It's not going to be straight away because I want to get it printed and make sure it works. Now we get to the sort of fun bit. Now this is this layer here is part of the T values section, T names even. So what that does, it appears on the silk screen. So we'll have a silk screen layer that looks like a banner going across. And the other layer that I turned off earlier just to make things a bit easier to read is the T stop layer, so the top stop layer. And essentially what that does is it stops any solder mask from going on that area, and it removes any silk screen and just leaves bare copper. Whether it's tin plated or whatever it does with that soldering thing where they dip the soldering the boards in, it gets coated in silver essentially. It's not silver though, is it? It's like solder. Whatever. I'm getting off the point. But the point is, it's pretty crap, as are most of my projects, and I'm happy to admit them. The learning I get from them isn't crap, but you know what they end up looking like is something else, isn't it? So this has a bit of text, and I've just put it onto the T stop layer. It's vector text. It's huge, 200, whatever that measurement might be, and it's going to sit inside that banner. So that will be bare copper or whatever they coat it with, and it will read through those. Through that solder mask there. Now it does mean I've had to route the top layer around it because this is sitting on the top layer, so I can't put any wires through it, but underneath I can, so that's fine. This is the format or the package for the badge that I used. So you can see it here. So that's the package. I've used a through hole one just because I have some here and they're pretty cheap. I had originally gone for one of these SMD ones, but they're really hard to find on eBay, so, or they're really expensive if you want to get them in the UK. So I need them fairly quickly, but I mean I haven't even ordered this board yet, so we're looking at a couple of weeks for this to arrive. But that's it. This is my entry to the badge challenge that you guys know nothing about pretty much. So I'm sure the Unexpected Maker will eventually talk about it publicly. But he hasn't yet. He's certainly mentioned badges, but not quite yet. So this will be my entry, and I'm very much looking forward to putting this together on stream maybe. I don't know if that's a good idea, but it will be fun because I have no idea if it's going to work. I mean, look at some of this dodgy tracing out. I mean, I've used some curved ones just for a bit of fancy lines. But most of them are all a bit strange. I mean, look at this one up here. That's just totally unnecessary. But it was a lot of fun to do. And I think I changed the design about 4 or 5 times because I wasn't sure what I wanted to do. And in fact, using the LDR was a little bit of I was experimenting on the bench. So yeah, that's going to be the badge. And you guys can make one as well if you want, or make something better, because I'm sure you all out there have done cooler circuits than this before. All right. I guess we'll talk about this again when it arrives. Peace out.